these that you guys want to talk about before we move on? Patrick?
The last one,
39? Okay. All right, so if I take a look at number 39, 39 said, dust mites are microscopic organisms that are found in most natural and synthetic fibers. All right, so it says that we have dust mites. All right, the length of them are 0.00042 meters, and the width of them are 0.12328 meters, and then it says an average mattress contains 2 million dust mites. Doesn't that gross you out? I try not to think about that. All right, they tell us to change each of these into scientific notation. So if I take a look at my length, I have 0.00042. All right, Patrick, how do I change that into scientific notation? Excellent. How many spaces did I have to move that? 4. 4 spaces. 1, 2, 3, 4. So this ends up being 4.2 times 10 to the, is that going to be a positive 4 or a negative 4 as my exponent? Negative. Why? Yep, this was a really small number. So what problem, what question specifically did you have on 39? All right, so you need to pay attention to your jumps. All right, this does not mean I'm saying this about you, Patrick, but if you're messy with your writing and you write really small, or if you're counting the number of places you have to move that decimal, might become challenging. So you need to make sure that when you're writing these out and moving that decimal, that you are neat. All right, and that you pay attention to moving the decimal from where it is to between individual digits to where you have to go. All right, on my width, I have 0.00028. Somebody change that into scientific notation for me. Addie? Okay. Yep, 1, 2, 3, 4. So go ahead and write that for me. Excellent. And then I would write meters after that because it is a length. All right, somebody do my number of dust mites for me. Amanda? 1, 2, 3, 4, 5, 6. So what's my number in scientific notation? Yep. And I'm going to say dust mites. Patrick, does that help you? Yeah. Awesome. Okay, put this away. Get your notes out. All right, so we are still in 4.7, so 4.7 continued. Today is the 16th. of December. We are talking about scientific notation. And what I want to talk about today is putting numbers, putting scientific notation numbers in order of least to greatest. All right, that's what we're going to be doing today. Okay, what you're not doing is you're not putting them into standard form. Do not change into standard form. I mean, you could. I'm not saying it's not possible. I'm trying to teach you how we compare numbers in scientific notation without having to put them into standard form. Okay, so the best way for me to do this is to give you an example. So I'm going to do the example to the left. I'm going to give you some steps, some comments and stuff to the right, notes to the right. All right, so this is our example. I want you to order 3.9 times 10 to the 6th. 3.9 times 10 to the 6th. 3,800,000 and 4.2 times 10 to the 5th. We are just starting with our notes, ladies. All right, we're in 4.7. We are putting scientific notation numbers in order of least to greatest. All right. Well, the first thing you do, so I'm going to do steps off to the right, and I'm going to do the work off to the left. The first thing you need to do is you need to make sure all the numbers are in scientific notation. So if you notice, that second number is not. All right, so I'm going to go ahead and put that in scientific notation. Someone tell me what to do. Just a little bit of a review. Nico, what should I do? Excellent. How many places am I doing that? Excellent. So what's that going to look like in scientific notation? Well, our standard form was really big. So is my power positive or negative? Positive. Excellent. That's always what I want you saying in your head. Is my standard form really big or is it really small? Really small, negative, really big, positive. Awesome. So what I'm going to do now is I'm just going to circle the numbers that I am comparing. That helps me so I know what my focus is. So now that all three numbers are in scientific notation, all right, this is the next thing you need to look at. This is how we order them. So, to order from least to greatest, I'm going to use A here. The first thing you're doing is you're going to compare the exponents on the tens. Smaller the exponent, the smaller the number. So someone tell me, what do you notice about the exponents on our 10? That's the first thing you compare is the exponents on the 10. Cullen?
3.9 times 10 6 and 3.8 times 10 are the same exponent.
So these are the same. And then what do you notice about the other one?
4.2 times 10 5
To the fifth?
is lower.
It's lower. So this is the smallest one. How many of you guys agree with that? All right. So I'm just going to write here 4.2 times 10 to the fifth is the smallest. That's what that helps us with. Okay. And eventually I'm going to write these out from least to greatest. All right. The other thing that we notice are these two right here have the same exponent. All right, so part B. If two numbers have the same exponent, this is when we compare first factors. All right, so I have 3.8 times 10 to the 6th, and I have 3.9 times 10 to the 6th. So I need to compare these two first factors. Which one of them is smaller? Which one of these two factors is smaller? Valentina? Yep, this is smaller. All right, so that means that 3.9 is our biggest number. So if I put these in order of least to greatest, it's going to end up being 4.2 times 10 to the 5th, 3.8 times 10 to the 6th, and then 3.9 times 10 to the 6th. So the first thing you're doing is you are comparing the exponents. If they're all different, then all you need to do is figure out which is the smallest and go up from there. If you have some numbers that have the same exponent on the 10, that's when you compare the first factors to each other. You guys cool? Okay, let me give you a bunch to work on. Okay? Who needs to see what's up there? Cool? Okay. Does anyone need to see this? Okay. So I'm going to put a couple of these on here. I'm going to have you guys get started on this first one. Order the numbers from least to greatest. Remember, you may not put them into standard form. 49,000. $240,000 and 3.3 times 10 to the 4th. Go ahead and get going. Remember, you can make sure all of them are in scientific notation to start with. understand.
So,
You need to accomplish all of these steps.
how should we show them?
Let's take a look and see. What's the first thing I need to do here? AJ, sit up. What's the first thing I need to do here? Go ahead, Patrick. Matthew? Excellent. So the first thing I'm going to do is I'm going to show the work changing these into scientific notation. So somebody tell me what change 49,000 in scientific notation. Go ahead, Matthew. Okay. Somebody change 240,000 for me. Sophia? To where? To where? Excellent. 1, 2, 3, 4, 5. So go ahead and write that for me. Okay. Okay, so someone tell me now, what am I looking at first? What's the first thing I need to look at? Brendan? So which one, what can you tell me by your analysis of the exponents? So I'm just going to write, just to help myself out, I'm just going to write biggest there. Okay? So then I have to compare these two, right? So tell me something about these two. All right, so then this might be the smallest, right? And this might be my middle. I'm just writing those notes there just so I can see what I did. And now somebody write this in order of the list in order of least to greatest. Ada? So this is everything that I should see. I have to see you changing these into scientific notation. I would highly advise that you kind of make notes as you go, but in the end, I need to have all of that. If they're all already in scientific notation, then I just need the list in order of least to greatest. Does that make sense? All right, let me give you guys another one. All right, go ahead and put those in order of least to greatest. Done, check with someone to divide. You guys are cool. You're in Cleveland. Right. She's in Maine. He's in Maine. All right. Talk to me about what you're going to do here. Talk to me what you're going to do. Colin, what am I going to do?
First,
So I went 4 places. Did you get 4? Awesome. Go ahead.
So it would be 1.7 times 10 to the negative fourth.
Okay.
When you look at the powers, 2.8 times 10 to the negative third is the greatest.
Excellent. Why is it the greatest?
Because since it's negative, you want the closest to 0.
Excellent. That's the thing to kind of keep in mind. Remember, these are negative exponents. So that negative 3 is actually bigger than the negative 4. That's the thing that's going to throw you off. Okay, so now what?
Then, well, 10 to the negative fourth is the same for 1.9 and 1.7.
Yep.
So you would compare,
This is hard, isn't it?
yeah, but it would be 1.9 is the second highest and the greatest is 1.7.
How many of you guys, so how many of you guys agree with him? I know this is hard. So forget about these now. Which of these is, so when we're putting this on a number line, these are not negative numbers. That's where people get thrown off. The powers are negative. These are not negative numbers. So we really are going to go with which one of those is bigger and which is smaller. Okay? So Cullen, which one of these two factors is smallest?
1.7.
Yeah, so this is my smallest number. What the tendency for a lot of people is that we see the negative exponents, so we're thinking these are negative numbers as well. And technically, if that was a negative 1.9, it would be the furthest away from 0, right? But these are positive numbers. They're just really tiny positive numbers. So this really is, 1.7 really is the smallest out of these two. Does that make sense to you guys? So negative exponents is kind of funky. You're first comparing negative numbers here, but then here you are comparing positive numbers. All right, so we really do have 1.7 times 10 to the negative fourth, 1.9 times 10 to the negative fourth, and then 2.8 times 10 to the negative third. How many of you guys got that one right? All right, that's a little funky, isn't it? All right, so let me give you some more practice. So the third one I want you to do, I'm going to put both of these up, and I want you to work on both of these. All right, so there's that one, and I'm going to do one more for you. Yes. Okay, let me explain it again. No. Let me explain this again. The first thing I'm doing is I'm comparing my negative powers. All right. The smallest is going to be the one that's closest to 0. Okay, so this 10 to the negative third is my biggest number. Do you agree with that? Because negative 3 is closest to 0 if we are comparing negative numbers. Everyone's pens are down. Okay, so the next thing I need to compare is I need to compare these two. These are not negative numbers. These are positive numbers. So if we think about putting 1.7 on a number line, and we think about putting 1.9 on a number line. So if I was to draw a number line, here's my 0, here is 1, here is 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Brendan, you hear me? Okay. So here's 1.7. 1, 2, 3. So this is 0.1. 1, 2, 3, 4, 5, 6, 7. Here is 1.7. Here is 1.9. These are not negative numbers. So when we're doing these really small numbers, we have to flip back and forth between comparing positive numbers and comparing negative numbers. when we are comparing our exponents, we are comparing negative numbers. So this negative 3 is bigger than a negative 4. But once we flip and we look at our first factors, now we are comparing positive numbers. And in your brain, you need to switch. If using a number line is helpful, use a number line. Or picture a number line. You know what I mean? Because when I say that, I want to make sure all of you heard that, because Brendan's not the only one that is going to be like, hang on a second, I need to rethink that. Every time I do this, I have to think the same way. I've got to think, okay, I'm doing positive numbers here, I'm doing negative numbers here, and you've got to keep those two comparisons separate in your brain and how to do them. All right? Okay, do this, please. So do the third one and then the fourth one there, please. Please stop tapping. All right, somebody do that first one for me, or number 3 for me. Valentina? And what do you end up getting? Excellent. So tell me, what is my smallest number, or what is my biggest? Start with whatever you have. So tell me something you know about these. Okay. Excellent. So I'm going to go ahead and put those in order then. How many of you guys got that? AJ, sit up, please. Awesome. All right, I'm just going to screenshot that so then I can put the second one. Nice job. The next one up. So I have 8.16 times 10 to the 6th, 635,000, and then 4.08 times 10 to the, what is that power on that last one? No. For number 4, is that a 5? Excellent. All right, somebody take care of this one for me. Go ahead, Danny. Excellent. So what is that going to be in scientific notation? Excellent. Okay. Excellent. How many of you guys are cool with this? All right. Again, for the work, you need to make sure that anything that's not in scientific notation is, and then whatever notes you want to put on there from them, I like circling as I go to analyze it, so I've made my decision, I've kind of picked it out, and then I list it. That's me. You don't necessarily have to do that. I find that helpful for me. You figure out what's helpful for you, okay? Particularly those negative exponents. I think those take the most thought, in my opinion, because you're toggling between comparing negative numbers and positive numbers. All right, you guys cool? Okie dokie. You guys are good to go. My students that were in Glee, ladies, why don't you come on over and show me your homework so I can make sure I just get it.